Hello friends, this video on metal and non-metal part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. So now, having told the reason why we are studying metals, the history of metals, let's understand the physical properties of metals. So metals has some physical property. If you see all the metals which we have seen just now in the previous slide, they shine. Everything has shine. So you can say that metal in the pure state has a shining surface. And please note this physical property is not applicable to all. Maybe there will be exceptions because the main definition for metal is anything which lose electron, right? So that is the main definition. So we don't define metal based on the physical properties, but on the chemical property. And the chemical property is that anything that lose electron. But when we have defined the metals, we observe that most of the metals, I'll say most of the metals have shining surface. So this property is called metallic luster. So if somebody asks you what is metallic luster, you can say that metals in the pure state, most of the metals in the pure state have a shiny surface. If you see the gold, it shines. If you see silver, it shines. Right? Copper shines. So most of the metals has a shiny surface. Right, and this property of the metal is called metallic luster. Hope you understand this. Most of the metals have shiny surface, and this property is called metallic luster. And please note, most of the metals I'm telling. So to do activity on this, because I just told you, you just want to prove yourself, right? So this is correct or not. So you can take some sample of iron, copper, aluminum, and magnesium from your lab, and it will look exactly like this, right? And just note the appearance of this. You'll observe that they are shiny. So what you can do, if the lab assistant has not given you a clean one, what you can do is you can clean that metals by rubbing them with sandpaper. You know sandpaper, paper which has sand stick to it. So you can clean stuff with that. So you can clean that and you see it glows actually. You know, it has a shine, and thus we can say that metals has shining surface. If you talk about the hardness, we'll see that most of the metals are hard. I'm telling most of the metals. For example, sodium is not hard. You can cut with knife. But most of the metals you can't cut with knife. You take gold, you won't be able to cut with knife. You take silver, you take iron, you take copper. It is difficult to cut with knife. So that's why I say that metals are generally hard. That means most of the metals are hard. It's not the rule that metals has to be hard. But most of the metals are hard, right? And the hardness varies from metal to metal. For activity, what we can do is we can take again iron, copper, aluminum, and manganese, right? And try to cut these with a sharp knife. And you'll observe that you'll not be able to cut these. And that's why we can say that metals are hard, right? You can do this in your lab. You get these metals, small piece in the lab assistant, and then try to cut them with a knife. You'll observe that you'll not be able to cut those things, right? Now you take sodium. Sodium is also a metal, and now we have to be cautious because sodium is very reactive. The moment you take out ribbon also, then you have to hold that with the pair of tongs and then try to cut it, and you see that you are able to cut sodium. It doesn't mean that it's not a metal. It is still a metal, because the definition of the metal was anything that loses electron is metal, and sodium very well loses electron. So in that case, sodium is a metal, but this physical property doesn't match. So most of the metals are hard, but sodium is not hard. So as I told, the physical property is not for all the metals. Some metals follow. In fact, you can see that 95% of the metals follow that, and maybe 5% doesn't follow that. So maybe we can, so since 95% follow, so we can still create a general rule saying that most of the metals are hard, most of the metals have shining luster, right? Now malleability. Malleability is something which can be beaten into thin sheets, right? So for example, if you see that you have this metal, you take the hammer, beat it, you can get something like this. The aluminium foil, if you see, and this container you must have used or you have seen in the hotels, when you take parcel, they generally put the stuff in this kind of container. They are all aluminum. So here, if you see, it is very, very thin, right? If you see, very, very thin, very, very thin. So the property of any metal to be beaten into thin sheet is called malleability. Please note, malleability is nothing but if you can beat a metal, this metal, let's suppose, into thin sheets, that property of that metal is called malleability. So most of the metals are malleable. Obviously, exception sodium, you can't put and make a thin sheet of that. But normally, if you take iron, also if you take aluminum, gold, they are all malleable, right? You can take hammer and you just hammer, and then you'll find that it will be a thin sheet. For this also, if you see that gold and silver are the most malleable metals. Gold and silver, they are most malleable metals, but they are not used for aluminum foils. Why? Obviously because it's very costly. So you can't afford a aluminum foil to wrap your food and throw it because it's very costly. So generally we use aluminum because it's a little cheaper, right? So for this, the activity is you can again take iron, zinc, lead, and copper, and then you place one metal and just hammer it. You observe that the thickness will decrease, right? For example, this is this much thickness. After hammering, it may become this much and expand in area. That means you see that you are decreasing the thickness, and if you keep hammering it, you may observe that you may get a thin sheet like this. And that's what, if you see that, it means that it is a malleable substance, right? Similarly, ductility is nothing but you have the ability to draw the metal into thin wires. Thin wires. For example, you have this metal and you convert into small thin wires. Then it's called ductility. Please note, malleability and ductility are different. Malleability means you have to convert that into thin sheets, and ductility is nothing but you have to convert them into thin wires. Both are different. Gold is the most ductile metal, and you know that you can make 2 kilometer length of gold from 1 gram of gold. 1 gram gold is such a small amount. Even from that, you can make 2 kilometer length of gold. It's such a ductile element, but still we don't use that to create generally the wires because it's very costly. So we use copper, right? So similarly, the next physical property is good conductor of heat. Most of the metals here also I'm telling most of the metals are good conductor of heat. And if you see these aluminum utensils in the home or steel utensils, I won't use steel now because steel is not a pure metal. Anyway, aluminum utensils, if you see, or copper utensils, if you see, why it is used? Because they are good conductor of heat. So if you use some burner in this gas stove, it should conduct heat, and that's why. And then only the food here will boil or cook, right? So metals are generally good conductor of heat. Good conductor of heat means it will conduct heat. They have a high melting point, and that's the reason if you see the same picture, that's why it is used generally for the utensils, because they won't melt so easily, right? If it has low melting point, for example, if you take paper, the moment you put it in fire, it burns, or in plastic, right? It's a low melting point. The moment you put it inside near fire, it melts. Those kind of stuffs can't be used for making utensils, right? Generally, high melting point stuffs are used to make utensils because it can resist heat. Because when you are cooking, it gets the heat. So if it is having low melting point, it may melt. So generally, metals are used because metals has high melting and boiling point. Tungsten has the highest melting point, whereas silver has the lowest boiling point. So this is something to remember. There is no concept in this. It's all based on observation. They have found that tungsten had this highest melting point and silver has the lowest melting point. For this, somebody would have done the experiment in the lab. They would have taken all the metals, find the boiling point, and they found that tungsten has the highest boiling point, melting point, and they found that silver has the lowest boiling point. Sodium and potassium has very low melting point. So sodium and potassium are metal, but generally it doesn't follow the physical property of the metal. It doesn't. It's not hard, right? It is not malleable, not ductile. So in that case, you can see that. But anyway, sodium and potassium have low melting point. They are all the exception here. Good conductor of electricity. If you see most of the wires, the wire which we use in home, they are all made of copper. Most of them, right? Because copper is a good conductor of electricity. So similarly, metals are generally good conductor of electricity. So most of the metals are good conductor. Most other metals are good conductor of electricity. Similarly, sonoricity, if you see the bells in the temples, right? So the moment you hit it, it makes noise. So that property is called sonoricity. It should make noise. If you take iron, if you hit the hammer, it will make noise, right? So if you have a coin, you drop it, make noise. Why? Because it's sonorous. And most of the metals are sonorous. High density. Metals have generally high density. They're heavy. They have heavy weight. And that's the reason if you see the weights which you use, or the hammers, right? The hammers, if you see, is use of is made of metals. Also the weights which you use in the shops, you must have gone, right? They use a weight. For example, this is 1 kg weight. 1 kg weight, 2 kg weight. All the weighing weights they use in the shops, you must have gone in grocery shop, right? Something like this, it says 1 kg. And they'll use it to weigh. Why they use it? Because they are all metals and they are heavy. So with a small size, you get 1 kg. So that's why they use the metals in that case. So the point I'm trying to say is metals have high density. And here iridium and osmium has the highest density, whereas lithium has the lowest density. Please note, lithium has the lowest density and iridium and osmium has the highest density. So generally metal has high density. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.